Okay. Now then, this equation right here, this is the model that we use to show our transformations. It looks horrible, but that's all the possible transformations all in one. I'm not going to be doing this. We're going to be taking it in smaller baby steps so that you can actually see what's happening. But this is the model, and I'm going to use different colors to kind of organize it for you guys. But the way this works is just like any other function that we were transforming. We've got it broken down to what affects the x value, your input value, and what affects the output value, your y value. All right, so the first thing I want to go over is this, what it says trig right here. This is where our function goes, be it sine, cosine, or tangent. Now, we haven't talked about tangent functions yet. That's going to be in a couple of days. But just know that's what this is representing. And so then x is our theta, our angle. And what we have been graphing is y equals sine theta or y equals cosine theta. So it's very simple. That's very simple. Now we're adding in all of these different possible transformations. Okay. The first transformation right here is your plus or minus. If you have a minus sign out here, that affects your vertical reflection. Vertical reflection. Just like on a parabola. If your coefficient is negative in front of your, in this case, in front of our sine, cosine, or tangent function, it's going to be reflected vertically. As far as A goes, this represents a vertical stretch or compression. So how wide it goes, or how or tall, I guess you could say, stretched out vertically, and then how close together it is. This D value out here, plus or minus, this one is vertical as well, and this one has to do with our vertical shift, whether we move up or down. Now, this value right here sometimes can be written in the very front. Okay, it's written in the very front, but what I want you to notice is that it is not within these grouping symbols. So whether it's in front or at the back, this number out here has to do with your vertical shifting. Now, just like our others, like especially quadratics, that's one that I think of, we wrote it out in a way so that we could see what impacts it horizontally and what impacts it vertically. This value right here, which normally would be the coefficient of theta, this value is the horizontal stretch or compression. And if you remember, just like any other function we did, the horizontal changes are always the opposite of what it indicates in here. It's always going to have the opposite effect. And someone asked me this morning, they put it in these terms, does the wife always do the opposite of what you ask in the house? Okay, and that's, I think that's what somebody had used before, that whatever it's asking you to do, it does the opposite when you're right here in this grouping symbol. Okay, now the coefficient right here for theta always needs to be 1. So if there is a value that is a coefficient, we tend to have to factor it out, because it has an impact on our phase shift, okay, or our horizontal shift. So make a note that the coefficient of theta should equal 1. And then this B value, this value here, not B, I'm sorry, C. The C value right here, this is our horizontal shift. Now, there is other terminology that can be used, and it could be called a phase shift. So I want you to write that down. Phase shift is your horizontal shift, where we can move left or right. Okay, let's take a look at our vertical transformations. And on this problem, it's just going to be, it's going to be cosine with these vertical adjustments. But remember, you always have to start off with your 5 key points. And we did that when we graph sine and cosine. Who remembers what those 5 key points are, those angles? Zero, pi over 2, 3 pi over 2, and then 2 pi. So these will always be the angles that we start with. And then what are the output values for those angles? 1, 0, 0, and then positive 1 again. Okay, so we've got our key points. Now, this parent function is going to be transformed. We are going to vertically stretch it by 2, so that's times 2. And then this plus 1 over here will be added after we do the stretch. We have to do it in that order. Think of order of operations. We got to multiply before we add. Okay, so now then, if we started at 1 and we multiplied it by 2, we got 2 plus 1 is 3. So we're going to have a point at an output value at 3. Do the same thing with all of these. 0 times 2 is 0, plus 1 is 1. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. Then we've got 0 times 2 is 0. Again, it's just going to be the same thing. It's repeating, so we've got 1 right there. And then last but not least, we've got, and then 1 repeats that value, output value, so you've got 3. So I always mark out my originals so that I don't accidentally graph them. Okay, now we're going to plot these points on the graph, but here's the thing. You got to make sure you understand how this graph is scaled. Notice they're only showing whole pies on there. So what is each one of these little increments? Okay. Fourths. They are fourths. So this is pi over 4. Then you've got pi over 2. 3 pi over 4 pi. What I would do is go in here and between all your whole pies, put your half pies. 3 pi over 2 is between pi and 2 pi. And our pi over 2's are always going to be odd numbers. 1, 3, then you go back around up to 5, then 7, and then 9. Okay. Now, there is a number 1 up here. I don't want that to be scaled like to have 4 units equaling to 1. We need to get everything to fit on here. So 1 unit will be 1, okay, vertically, so we can get this graph to fit. Now, we're going to plot our points. We've got the first point is at 0, 3. Then we've got pi over 2, 1. Then we've got pi, negative 1. 3 pi over 2, positive 1. 2 pi up to 3. Now, can you continue plotting these points? Continue the pattern. We came down here to 1 I put pi over 4 there. At a pi over 2, so we're going to go down there to 1, whole pi negative 1, half pi 1, whole pi 3, half pi 1, whole pi negative 1. So I want you to continue plotting those points and then go through and connect them. Oopsie. Making your curve all the way through. Okay. All right, once we've got everything plotted, now what we want to do is we want to determine like what's changed with this graph. So we're going to identify some key features here. The first thing I want you to do is draw a horizontal line through the very center of this graph. If you were to draw a horizontal line through the center, it would no longer be the x-axis, which is what it normally was. Instead, it would be right here, where x is equal to 1. That is the middle, and it's super important to find that middle just to make sure that you get a lot of your other features done correctly. That middle has shifted up because our graph told us to shift up. So that shift affected where the middle of our graph was. And then our amplitude, remember our amplitude is always the distance from the highest point to the middle or the lowest point to the middle. And our amplitude is no longer 1 like it is for normally for cosine, but instead it's stretched to 2. The reason why it's stretched to 2 is because we had a vertical stretch right here. So that vertical stretch is your amplitude. So make a note of that, that vertical stretch is your amplitude. All right. Then the next thing we want to determine is what is our cycle, the period. How long did it take for us to complete a full cycle? Well, if you notice, we started here, went down, and then went all the way back up, and then it started to repeat again. So between 0 and 2 pi, we completed one full cycle. So we didn't change that because nothing changed horizontally. So one full cycle, or period, these two terms are used interchangeably, is equal to 2 pi. Now we're going to use this information that we've got here to answer these questions. Okay? So now then, if you will take a look at the domain, did our domain values change at all? What we're able to input into the... No, we're still using all angles. So it's negative infinity to positive infinity. What about our range? Did the changes impact our range? Yeah. What's our lowest point we use? Okay, so -1. And what's our highest point? +3. So -1 up to 3 in our brackets. Our amplitude, 2. The period, 2 pi. The phase shift, that is none. We didn't shift it left or right. We did shift vertically, and we went up 1. So you either need to put +1 or up 1. But you absolutely have to give me the direction. Okay? You have to give me the direction, or I have to count off points on a test. Because you'll be asked these types of questions. All right. So now then, that's all the stuff we're going to get from this graph, all the little detail information, and a lot of this we can get from just our equation alone. All right, now let's take a look at sine. We're going to do the same thing, except we're going to use sine, and our changes are, instead of stretch, it's going to be compressed, and we're going to shift the opposite direction. So let's go ahead and do our 5 key points for sine. What are our angles? 0 pi over 2 pi, 3 pi over 2, and 2 pi. Same as cosine. And then our output values. Sine of 0, 0, sine of pi over 2. Oh yeah, I was going to put negative. +1. Then we go back to 0, then -1, and then 0. Okay, let me get rid of my little blooper there. So always using these same 5 key points, making sure your output values are correct for sine and for cosine. Now, the changes that we're going to make to it, again, are all vertical because they are outside of the grouping symbols. The first thing we're going to do is multiply by 1/2, and then we're going to subtract 1. Okay, so when you start off with 0, 0 times 1/2 is still 0, minus 1, we're going to shift down to -1. Half of 1 is 1/2, and take 1 away from 1/2, and you've got a -1/2, or 0.5. 0 repeats. So I'm going to go ahead and do this last 0 because it's going to be the same. But now we've got -1 times 1/2 would put us at a -1/2. And if I subtract 1 from a -1/2, I'm going to be down to a -1.5. So a -1.5. These are going to be our new points that we're going to plot. And this is the exact same graph as the one above. So what you want to do is go ahead in here and mark your half pies. And we're going to scale. I still want to use the scale that we did above vertically because it's going to be really scrunched in, but I want you to see that scrunched in, to see the impact that it actually has. So let's just go ahead and start plotting our points now. We've got 0, -1. So we're right here on the y-axis. Pi over 2, -0.5. Oopsie, oopsie, I went too far. There we go, -0.5. Pi, -1. 3 pi over 2, -1.5. And then at 2 pi, we're at -1. So my half pies are kind of in the way to see my points, but I'm going to go ahead and trace those. Two by 1, 2, 3, 4, 5. What did I do wrong? I went too far again. I went to -2, didn't I? I was going, dang it, that isn't curving right. I don't know where -1 is, obviously. We had to curve back up. All right. Notice your pattern right here. We stopped, but we're going to continue. I want you to continue graphing sine all the way through the rest of this. So, we're at our middle. We go back up to 0.5, to our middle, 7.5, or 7 pi over 2, we're at -1.5. Back up, back up, back down. So you can see your curve there. And notice it is very much scrunched, okay? But again, I want you to see it's a vertical compression, so it's only going to be half as tall as what it normally is, you know, half the height and half the depth. All right, so now then, did this change our domain, our input values at all? No, so our domain is still -infinity to +infinity. Did this change our range? Yeah, it did. If you draw a line through the very center of your graph, okay, you can see from that center to the highest point or to the lowest point, we've got a big difference there. So we've got it compressed so it's not stretched nearly as far. What is our range value? How low do we go? Okay, and how high do we go? Closer to 0, -0.5. There we go, -0.5. Lowest point, highest point. And our amplitude now is just how much? 1/2, and you can put 1/2 or 0.5. I do not care. And remember, we get that from our equation right here. This is our amplitude. Our period, how long did it take us to complete one whole cycle? Did it change? Middle, up, down, back to middle. Its cycle is still 2 pi. So that did not change. We didn't have a phase shift, but did we have a vertical shift? Which direction? So I want to see down 1 or -1 to show which direction you go. And let's look on page 7. And this is going to be our horizontal transformations. Okay, our horizontal. Now, notice where the values are located. They're around the grouping symbols. And some people might say, oh, wait a minute, that 1/2 is outside the grouping symbol. Technically, it's still within because it's on the right side of cosine there. So if you want to put brackets around it to show it, you can, but you don't have to have those brackets. All right, those brackets don't have to be there for that 1/2 to be considered part of it. All right, next thing. let's go ahead and start our table. Get our table of values here. Theta and cosine theta. Now, because these are within the house, inside those grouping symbols, we do the opposite. What is the opposite of multiplying by 1/2? Dividing by 2, right? Okay, so, but instead of saying dividing by 2, I like to say multiplying by 2. Okay, so multiplying by 1/2 is like multiplying by the reciprocal. And then your phase shift is plus pi over 4, so really, wait a minute. Did I say the opposite of multiplying by 1/2 is dividing by 2? I was sitting there going, that does not make sense. I was going, where am I getting confused? So instead of multiplying by 1/2, or multiplying by 1/2 is equal to dividing by 2. So the opposite is multiplying by 2. Okay, sorry guys, sorry, it's a Monday. It's a Monday. So pi over 4, this is being added in here. So what do we do as far as the transformation goes? What's the opposite? Subtracting pi over 4. All right, now this is what I'm talking about as far as you're going to give yourself a lot of room over here to kind of show your work so you can see later what you did to get the result, because that's the thing. You got to be able to look at this later and go, wait a minute, how did I get those numbers? Let's go ahead and fill it in. We've got our 5 critical points: 0, pi over 2, pi, 3 pi over 2, 2 pi, and our output 1, 0, -1, 0, and 1. Get those 5 key points going. All right, now I'm going to take this angle, 0, I'm going to multiply it times 2, and then I'm going to subtract pi over 4. 0 times 2 is 0. 0 minus pi over 4 is a negative pi over 4. So that is going to be where I end up starting. Why? Because I shifted horizontally. Then I'm going to take my next angle of pi over 2. I'm going to multiply it by pi. And then I'm going to subtract pi over 4. What happens when I multiply pi over 2 times 2? Yeah, they cancel and you have pi. Now, what is pi minus pi over 4? And I want you to visualize the unit circle. If you're at pi and you go back pi over 4, where'd you land? 3 pi over 4. Okay, now, once you've got 2 of these developed, this is where the pattern begins. What did you do to get from negative pi over 4 to positive 3 pi over 4? What did you add to that to get from one to the other? A whole pi, or 4 pi over 4. If you add 4 pi over 4, you're at 3 pi over 4. So what that means is each one of these, you're going to add 4 pi over 4 to it. If you don't understand that, then bear with me. Let's keep going so that you can eventually see what I'm talking about. So now we're going to take pi, multiply it by 2. That gives you 2 pi. And if you're on the unit circle and you're sitting at 2 pi and you go backwards pi over 4, what pi over 4 are you sitting on? 7 pi over 4. And here's what I'm talking about. If I were to add 4 to 3, I get 7. That's my 7 pi over 4. I'm adding a whole pi to it, 4 pi over 4. When you add fractions, the denominators are the same. You just add the coefficients. So if I added 4 to 3, then what would I add 4 to 7, and then I would be at 11 pi over 4. I add 4 to 11, and I'm at 15 pi over 4. So once you see that pattern, it's so much easier to continue, because those are the ugly ones that are kind of messy to get. So now then, I want you to make a note down here. The pattern, add 4 pi over 4 to each previous new angle. So we're just increasing by 4 pi over 4. Do y'all understand what I'm saying about this pattern? Are we doing okay? And if there's any of you that go, man, I don't see it, talk to me later, okay? Because it's really helpful to see that pattern. All right, so real quickly, let's go ahead and start plotting these points. The scale is the same. We've got to have our pi over 2's in here. Or actually, we don't have to have our pi over 2's in here, because look at what we've got. What are all of our angles counting by? Pi over 4, right? And each one of these is a pi over 4. So this is 1, 2, 3, 4, 5, 6, 7, 8, and so on. They're just pi over 4. So we can real easily plot those. Our first point, we're going in a negative direction. So let's get rid of those, and we're going to scale the verticals by 1. So if I go to negative pi over 4 and up 1, then I'm going to plot my point right there in that second quadrant. If I go to 3 pi over 4, then I just start at 0 and go 1, 2, 3, and plot my point at 0. Then I go to 7. That's 3, 4, 5, 6, 7, and I go to negative 1. If that's 7, 8, 9, 10, 11, and I go back up to 0. 12, 13, 14, 15, and I go back up to 1. And then I'm going to connect my points. I only have room really just to do 1. All right, now what we're looking at our domain and our range. Our domain doesn't change. It's still negative infinity to positive infinity. But our highest and lowest point is still the same as our parent function, because we didn't change anything vertically. So we're still, lowest point is negative 1, highest point is positive 1. Our amplitude didn't change because we didn't change anything vertically. So our amplitude is still 1. A period, okay, the period did change because we started at negative pi over 4 and went to 15 pi over 4. So I am at 15 pi over 4 plus another pi over 4 from the other direction. That gives me a total of 16 pi over 4 units, which reduces down to 4 pi. So here's what I want you to note. This is double. Isn't that double the normal? What's the opposite of the 1/2? Is 2. It doubled. It stretched it. Now, here is the formula for finding the period. Period is equal to 2 pi over b. What is b in this situation? 1/2. That's this value right here. And so if we've got 2 pi divided by 1/2, we're really multiplying it by the reciprocal, which is 2, and that gives us 4 pi. So this is the formula. So this is super important that you've got that down. Our phase shift, where did we move? How many units? Horizontally. Pi over 4, which direction? Left. So since we moved left, you better put negative or left pi over 4. You got to show me you moved in a negative direction. Does that make sense? If you leave it as pi over 4 because this is positive right here, that's not the direction we moved. All right. And did we have a vertical shift? Nope. That is none. Okay, so we are going to pause there, and I will do... Okay, for this last problem, what we're going to do, same thing. Let's start out by plotting our 5 key points, or putting them in our table. We've got 0, pi over 2, pi, 3 pi over 2, 2 pi, and then we've got, for sign, we've got 0, 1, 0, negative 1, 0. All right, now, these changes, the multiplying by this 3 right here, remember we do the reciprocal. We multiply by the reciprocal, which is 1/3. And the opposite of subtracting is adding. Okay, so we do the opposite. So I'm taking, oopsie, sorry about that, 0, and I am applying these changes to it. So we've got 0 times 1/3 plus pi over 3, which is 0 plus pi over 3 is pi over 3. That's going to be my new angle. I'm going to do one more to see if I can determine the pattern. Okay, so then I've got pi over 2 times 1/3 plus pi over 3. Okay, this would be pi over 6. Pi over 6, if you think of that as 30 degrees, plus pi over 3 is 60 degrees. 30 and 60 is 90, which is pi over 2. Oh, check it out. It's the same. Isn't that crazy? All right. Now, as far as the pattern goes,
Olivia and Grace Johnson to the front, please. Olivia and Grace Johnson to the front.
This is increasing by pi over 6 radians, or 30 degrees. So if you go around the unit circle, what's 30 degrees past pi over 2? It is 2 pi over 3. What's 30 degrees past that? That would be 5 pi over 6. What's 30 degrees past that? We have pi. Now, if this troubles you, if you struggle with that, you can go ahead and work it out, do the math out here and everything, to do whatever you need to do to get those answers. All of us work a little bit differently. But as far as the pattern goes, we are adding pi over 6 to the previous new angle to get the next angle. That's our pattern. We're adding pi over 6, or 30 degrees. All right. So then when we go to plot these points, since all of these are by pi over 4s, we're going to have to be pretty careful about where we plot these points, okay? Because these are pi over 3 and 6. So I know this one is a pi over 2. This one is would be 3 pi over 2. All right, so we've got that going. So we're going to start with pi over 3. Pi over 3 is close to, oh my goodness, if they have one more announcement. Pi over 3 and 0. So pi over 3 is 30 degrees from pi over 2, so it's going to be closer right here to pi over 4, which is 45 degrees, right? 60 degrees would be closer to it. And then the next point is pi over 2, 1. And then 2 pi over 3 is going to be right here. The next point, 5 pi over 6 at negative 1, is going to be closer to pi. And then at pi, we will be back at 0. So we've got all of these connections right here. Okay, so we got one cycle graphed. We're going to continue the pattern though, all right? And this can be a little bit tricky here. So we're going to continue, notice these are like 30 degrees apart. So we're going to go in our next spot. We are going to pi, after pi, we are going right up here, 30 degrees from that, and then we would come back down to 30 degrees on the other side, and then down to negative 1 and 3 pi over 2, back up to the to 0, and then on over to almost to 2 pi. There we go. This one's a little bit trickier to get at. I'm just going to stop right there. I just kind of wanted you to have an idea so that you could see how scrunched this is together. And notice that we started at right here at pi over 3, and we ended right here at whole pi. Okay, so from pi over 3 to whole pi, to figure out that period, you can take pi and subtract the pi over 3 from it, and that will give you what lies within this realm right here, because this wasn't part of it because we shifted over, so only this is within that period. Okay? But another way to determine that period, remember, is period is equal to 2 pi divided by b. And since b was 3, that was this number right here. Since the b value was 3, our period is 2 pi over 3. All right, so make sure you have that formula down for you. Our domain did not change. Our domain is still all real numbers, negative infinity to positive infinity. Our range did not change. It still goes from negative 1 to positive 1. And our amplitude is still 1. Vertically, nothing changed. Notice, though, we shifted right here. This was our shift. We have a shift of pi over 3. So the phase shift, we moved in a positive direction, or you could say right pi over 3. Vertical shift, there is none. All right. So just to kind of clarify what we've done is we've identified horizontal changes, and these horizontal changes can cause things to shrink and come closer together horizontally, or it can be stretched out wider horizontally. And then the vertical changes are vertical changes. I don't know what I did with my paper. There it is. The vertical changes, we can be stretched out vertically, or we can be compressed and come in closer together and be scrunched from the vertical direction. All right. We're done.